morning everyone, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next part of Unit 3rd, that is again related to probability. So, in today's lecture we will discuss about random variables. So, it is a mathematical tool to assign an event or a outcome of a sample space into a integer value or a number. So, that is known as random variable. So, to each outcome omega I we have to assign a number that is denoted by x omega I, where I will vary from 0 to up to let us say there are 5 samples exist in a sample space. So, I will vary from 0 to 4 or it can vary from 1 to 5. So, that is the way we can represent a random variable. So, that is the notation of a random variable. Examples of this are ASCII code for symbols, then letter grades get mapped to 0, 1, 2 up to 4. So, purpose of this is of this particular mapping is to allow numerical analysis, such as we can draw plots, we can calculate sum, that is mean or variance, sets defined via inequalities, probability functions. So, these are some of the purposes that we do this random variable analysis. So, there are different types, two different types of random variable, that is continuous time and discrete random variable. So, first we will discuss what is discrete random variable. So, for now we will limit ourselves to discrete random variable. A discrete random variable x can take on values only from a finite set, a countably infinite set, example the integers but not the real ones. So, basically in case of discrete, when we talk about discrete signal or discrete time signal, discrete signal analysis, discrete random variable, it will take the values only at the integer points. It will be defined at specific point of time, like it cannot be defined for 1, 1.2, 1.3, 1.4, between 1 to 2 you can say. Let us say this is the axis, this will be 1, this will be 2, this will be 3 and so on, this will be 1.1, 1.2, 1.3. So, this is not the way that the signal will be defined for all the values that exist between 1 and 2. It will be defined only for the integers value which can be countable. So, let us say it will be defined at 1, then 2, then 3, then it will be defined at 4. So, this is how the discrete mapping is been done. So, the finite set case is the more important one here. Example, x can take only values in the set that is 0, 0.5, 1, 1.5 up to 10, x can take only values in the set that is 0, 1, 2, 3 and so on. A random variable x can take any value in the interval 0 to 1, is not discrete. So, that is known as continuous time random variable. So, when in an definite slot, let us say infinite number of values can be taken for every point, then it is known as continuous time random variable. Then comes the conditional probability and independence. So, consider two separate observations from one or two experiments. So, given that you know what was observed for one of the outcomes, what is the probability that you will get the other outcome. So, a probability for a particular experiment A that will come, and given that probability B already exists. So, that is known as conditional probability. So, probability that you observe A given that B has already occurred. So, that is known as conditional probability. So, that is the formula for conditional probability, that is probability A by B is equals to probability A comma B divided by probability of B. So, note that this is the condition for this particular formula, that probability A by B should be greater than equals to probability A comma B, because probability of B should be less than equals to 1. So, independence is if B provides no information about A, then the knowledge of B does not change the probability of observation A. So, in this case A and B are known as the independent events, means the occurrence of any event does not affect the occurrence of the other event. So, that is known as independence property. So, if A and B are independent, then probability A comma B is equals to probability of A and B. Since these are not dependent on each other, so we can simply multiply each one of the probability and we can get this value, that is A comma B. So, that is the case for conditional probability. Now, probability versus conditional probability and the joint probability. So, these measures the single event and this will measure the multiple events. Multiple events means if we draw an outcome from an experiment, then multiple events will be there, and in single event there will be a single experiment that will be conducted. So, as we know that P A by B is greater than equals to P A comma B, and what about this particular value, that is P A versus P A by B. So, that will be the value that we have to decide. So, we know that if A and B are independent, then only this equal sign will be there. So, we have to consider this one. So, otherwise it could be higher or lower than P A. So, that will be the condition for joint probability and conditional probability. Now, next is this is an example, probability of characters in English text. So, that is one of the one or two numericals that we are going to cover to understand this much better. So, first is what is the probability of getting a specified letter. Let us say there are 26 letters of exist, alphabetical letters are there. So, most probable letter is E. So, probability of E will be 0.127 and Q and Z are least probable. So, its probability will be 0.001. So, this is how we can calculate the value of probability of an occurrence of a specific letter. Now, next is if you know the current letter, what is the probability of getting a specific letter in the next position. So, these are some of the guesses that you can find out. Now, next is probability function for discrete random variable. So, after after knowing that what is discrete random variable which will take discrete values in an interval. So, for discrete random variable x, the probability function is f x x, which is defined by this is probability density function is related to probability of occurrence of event x. So, and this is the probability this is the property of the probability, the summation of all the PDF should always be equals to 1. So, let event B letter grades A, B, C, D and random variable x maps these to a number, means if A will be there, then that will be mapped to a number, if B will be there, then that will be mapped to a number, means an event of occurrence of an alphabet is mapped to any of the number. So, assume these probabilities. So, for probability of x is equals to 0, it will be this one. So, these are the values, and corresponding to this we can find out the PDF, and which can be plotted on this graph. Let us say for 0 it will be 0.05, for 1 it will be 0.15, for 2 it will be 0.3. So, this is how we can plot the PDF of a given random variable x, which is discrete random variable. So, that is why it is been defined at discrete time, discrete points. Now, next is CDF. So, there is a relation between CDF and PDF of a random variable. PDF is the differentiation of CDF and vice versa. So, what is CDF? CDF is cumulative distribution function. For random variable x, the CDF is denoted by this one. You can see the notation. For PDF you have to use small x, for CDF you have to use capital X. So, that is the difference between the notation of both the distribution functions. So, it is defined as this particular formula, that is f x x is equals to probability x is less than is equals to x. So, for a discrete random variable, the CDF and probability function are related by this particular equation. So, for our example, we can in the previous slide we have discussed this one, that is the PDF of a given random variable x. Now, we can also plot the CDF of this random variable. So, this will be f x x versus x, and we have to draw a staircase kind of waveform, which means that the differentiation of this particular the integration of this impulse function results in a unit step signal which is like this one, and that will be the you can see that this is non decreasing one. So, this is a case of CDF. You can plot the CDF from a given PDF function. Next is mean of random variable. So, mean of random variable is equals to the expected value that we have to calculate, and expected value formula is very simple. It can be calculated from any PDF of a given random variable. So, let us say we have a random variable x, we have to calculate its mean. So, mean will be denoted by mu, which will be equals to expected value of x, and its formula is integral over the limit minus infinity to infinity f x x into x dx. What does it mean? This will be the PDF of the random variable x multiplied by the variable itself, and it will be integrated for the interval minus infinity to infinity. This interval can be changed depending on the PDF distribution of the random variable x. If it is been it exists between a to b, so that will be changed from the interval a to b, then PDF of this random variable x multiplied by x itself, and we can calculate the value easily. So, this is how we can calculate the PDF of mean of the random variable by using the expected value. Secondly, we can also calculate the variance of this random variable by using the concept of expected value. So, variance formula will be expected value of x square minus mean square. So, that will be the variance of the particular random variable x. Now, in this slide you can see that there is data, the means consider a random variable x which is been defined as score on a test, then data is been given at means n number of students are there, and we have considered 100 students. So, we can calculate its average simply, and this is called as data analysis or empirical view. Now, next is what I have explained in the previous slide, that how we have to calculate the mean of that particular random variable x. So, for discrete random variable, that is x, its formula will be this one. This is in the discrete case, and I have discussed the continuous time case, where integration will be replaced by the summation. So, this is the notation, and if there is a some constants exist, then the formula will be changes to this one. So, that is the theoretical view. Now, next is the variance. Its formula I have discussed, that sigma square variance is equals to expected value of x square minus, this will be the mean of the random variable which we have calculated in the previous slide, and if there is 0 mean, then this will be the formula, this value will become 0 in this case. So, that will be the variance of random variable. Now, next comes the correlation between the random variables. So, this is a very important concept where you have to analyze different variables. Here exists only one variable or two variable we are discussing, but when we are analyzing, when we are doing the data analysis, let us say there is an Excel sheet and there are different number of entries are there in that data sheet, and there are number of variables like the age is there or salary of a person, then there are different variables. These are kind of variables only which are having the data set, let us say for 100 employees, then that has to be analyzed. So, the correlation plays a very important role, which shows that how two variables or random variables are correlated with each other. It has been plotted in a kind of scatter plot. This is a kind of scatter plot only that will show the correlation between two random variables, three random variables. This is the analysis that we can done using the correlation concept. So, consider a random experiment with two outcomes. Let us say there are two outcomes are there. So, two random variables x and y of height and weight. So, how this height and weight is correlated to each other. So, you can plot a graph, that is a 2D graph which has y and x two random variables. Then positively, if it is correlated, then you can see the points on the scatter plot are closely packed with each other. If it is negatively correlated, so this picture is showing the difference between the correlations, like this is the positive correlation, and you can see that this is a kind of increasing graph and the points are closely packed with each other. In this case, this value is random variable x minus mean of that random variable, and this will be y minus mean of that random variable. Now, next is zero correlation. Zero correlation means the, in case of the scatter plot, all the points are scattered over the 4 quadrants of an graph. Next one is the negative correlation, where you can see that this is a kind of decreasing graph. So, that is negative correlation between the 2 random variables x and y. Now, the theory is covariance. To capture this, we will define a covariance formula. So, covariance formula is sigma x y is equals to expected value of x minus x bar into y minus y bar. So, sigma x y will be is equals to x I minus x bar into y I minus y bar into the probability. So, if the random variables are both 0 mean, so sigma x y is equals to expected value of x y. If x is equals to y, then this will be the formula, that is sigma x y is equals to sigma x square is equals to sigma y square. So, this is the case when 2 random variables are equal to each other, then their mean then their variance will also be equals to the covariance of the between the 2 random variables. Now, this is also the probability properties related to this case, that is if sigma x y is equals to 0, then this will be the correlation of x and y. Now, next is independence versus uncorrelated. When x and y are independent to each other, then f x y is given by this formula. When it is uncorrelated, then it will be shown by this particular diagram. Then next comes the for random vectors, that is x is equals to, when we are considering the random vectors not the random variables, then this formula will occur, that is x is equals to x1 to xn, which is transpose of this one. Then we can calculate the correlation matrix and covariance matrix from this particular formula. So, this is all about today's lecture. Thank you.